Hello and welcome to Olympiad Tutorials. I am Dr. Aparna Adhikari and today we are going to learn an interesting concept, that is fun with magnets. We'll be solving few Olympiad questions. So let's begin. In the given diagram, compasses are used to plot the magnetic fields around a bar magnet and the poles are marked N for north, S for south. Which of the following diagrams correctly show the expected field patterns? So here you can see, after observing, the correct option will be option number D, because the magnetic field line is directed from the north to the south and outside the bar magnet. Now just if we extend it, it will be in this manner. This will be the arrow. Similarly, in this pattern, you can see the magnetic fields. Even in the books, you can see the arrows are directed in this way. And even in this side also, you can see. So this will be the correct option, option number D. Here you can see three magnets, and if they are dipped in the heap of iron fillings, then we have to tell which magnet is having the most magnetic power, or you can say the strength of which magnet will be greatest. So after observing, you can see the iron fillings are sticking more on the X magnet, and then which is followed by Y and then the Z. So here your correct option will be option number A. X is greater than Y is greater than Z. So because more is the amount of the iron filling stick to the magnet, more will be its strength. Hence the correct order will be X greater than Y greater than Z. Here you can see a student has hung a magnet on a spring coil, which is shown, and the coil is a bit extended, and the first magnet is shown in this way. So the question here is, what has caused the magnetic, you can say what has caused the spring coil to extend? Option A, magnet P was too heavy for the spring coil. Magnet B repelled the magnet Q. Magnet P became stronger and magnet Q attracted the magnet P. So here you can see the correct option will be option number D. This is because the unlike poles were facing each other, causing the two magnets to be attracted to each other. So here you can see, if unlike poles are brought together, then they have the tendency to attract each other, and if they are of the same type, then they repel. So as the magnet P is moved towards magnet Q, the spring, it will get extended. So correct option will be option number D. Question number 4. Lisa did an experiment to find out which part of the magnet attracts the maximum number of pins. Which of the following readings may be correct regarding the number of pins attracted by different parts of the magnet? So here you can see the picture. As you can see the options also, your correct option will be option number A, because P and S, they represent the poles of the magnet, and always you must know that the magnetic poles, they extend the strongest magnetic force as compared to the other points like Q and R. Here the terminal points are N and S, okay, and which is shown by P and S. So here P and S are going to attract the maximum number of pins as compared to Q and R. Option will be option number A. Next question. To demagnetize a magnet using the heating method, which of the following is the correct step? So here your option number A will be correct. So demagnetize means the magnet will lose its magnetic property. So heat the magnet to become red hot and allow it to cool in the east-west direction, which leads to demagnetize the magnet. So next question, Ashwini magnetized a piece of iron rod using stroking method as shown in the diagram. Which part of the iron rod becomes the north-seeking pole? So you know that most of the times we can induce the magnetic properties in the iron rod using the stroking method. So here the correct option will be option number C, that is R. Q becomes the north pole and R will become the north seeking pole. Next question, what will happen when 3-bar magnets are hung in the manner as shown in the figure below? So if you carefully see the picture, you can see option number D will be the correct option. Magnet Y will move towards the magnet X, because here you can see these are the unlike poles, south pole and north pole, they attract each other, whereas if you see the magnets Y and Z, here the like poles tend to repel each other. So your correct option will be option number D. Next question, magnets lose their properties significantly if, your correct option will be option number C, if they are dropped from a height repeatedly. Option number C. The magnet tends to lose its property when it is dropped repeatedly from a height. Next question. The north pole of a bar magnet picks up an iron nail. Which of the following option is correct regarding the pole induced in the nail? So here your correct option will be option number C, a north pole and the south pole. In which of the following a permanent magnet is used? Magnetic door catchers, loudspeakers, compasses, and all of the above. So here your correct option will be all of this, because we can see magnets even in the magnetic door catchers, loudspeakers, compasses, etc. Next question. How many north and south poles are present if a magnet is broken into 6 pieces without the loss of magnetism? So here your options are 6, 12, 2 and 0. So here your option will be, correct option will be option number B. And why the option B? Because each of the 6 pieces of the magnets will become individual magnets. Every magnet will have 2 poles, that is the north pole and the south pole. So total there will be 12 poles for 6 pieces of magnets. Next question. Two magnets are placed in a container as shown in the figure by some external force. What would happen if the force on magnet P is removed? Now here, after observing the picture, you can answer this question. The correct option will be option number B. Magnet P will repel magnet Q, and this is because since the like poles repel each other, magnet P will repel magnet Q. That's all for today's video. Hope you enjoyed this session. We have solved few questions regarding the magnets and it was quite a fun. So if you like this video, don't forget to subscribe my channel and like this video. And for online classes and other queries, you can mail me on my Gmail account, or you can also ask your queries and doubts in the comment section below. So let's meet in some another exciting video. Thanks for watching.